Hi, and welcome to the introduction to the AutoLST. My name is Peter Paul Bakker, and I'm a Java performance consultant, and I help agile teams with their performance testing. In this session, I will explain the why, how, and what of the AutoLST. Why an automatic load stress test is needed, how it is being put together, what the building blocks are, and what is the result and the outcome of the AutoLST. What does it deliver to projects? But first, I want to go back 4 years in time. 4 years ago, we had large releases. There were like waterfall projects. So at the end, when everything seemed to be finished, the performance tester would be called in. The performance test scripts were written. The performance test environment was set up, but it gave a lot of issues because it was always a last-minute thing. And before testing, there was barely contact with the development team. The performance engineer who would execute the performance test was located in another department. The communication was not very good. And as a result of that, we had a lot of failing performance tests. And when we finally had a running performance test, a large report was being created, which took a lot of manual analysis. And in that report, we could report blocking findings. And if blocking findings were found, a project could not go live. And very close to a deadline, that's very annoying to projects. And it was hard to fix everything on time. A lot of times, with the risk assessment, projects would still go live, knowing that there was an issue with performance, which maybe could be solved by throwing in more CPU, which is a costly affair. So, if we look at the performance testing of today, we see that development projects move to a more agile way of working, so they work in sprints. And performance testing is also being fit into this agile way of working. So we tried at the end of each sprint, which could last for 2 weeks, to have a finished performance test. To get that accomplished, we placed the performance engineer together with the rest of the development team. We did not create any large reports anymore, but produced a management summary, which consists of 1 page, stating what is good and what is bad. Blocking findings are now found earlier in the process, so there's still time to fix them, possibly and most of the time in the sprint itself. So there's a lot of positive effects of doing continuous performance testing. So what do we need to do this continuous performance testing? First of all, we need clear performance requirements, because without performance requirements, you cannot test automatically if a test is failed or was successful. Next, we need fast feedback. It would be best if developers would code their program and got instant feedback if they typed in something that would cause a performance issue later on. We're not there yet, but currently we have the just-in-time performance test scripts, which you can imagine that a developer is creating a new function, and the performance engineer who writes performance scripts is sitting next to him, and they can code the performance test script and the functionality together. For a performance test run, you also need a lot of test data, and you need stubs to test your development project in isolation. So you also need to create daily performance test data and stubs that act well with the performance script. So this is also a team effort. To get an automatic load stress test up and running, you need to do a lot of automation. It's not only to automate the test scripts itself, also to automate the setup of the test environment, for instance. And a lot can be done today with writing scripts that configure a complete system from scratch, including all the correct settings that are stored in configuration management. So where are we now? We have automated some of the parts of the load stress test. And the biggest wins that we got was to automate the scheduling of test runs, which means for each test run you need to do a lot of things, like restarting the server under test, clearing the log files, performing heap dumps for later memory analysis, and those would be done all manually 4 years ago. And currently those are all automated and run via a script. To check if there are any memory leaks and to see the details of the memory leaks, we have the heap analysis. And the heap analysis has been automated completely. And that takes away 2 days of analysis time for each analysis. The same goes for the test run analysis. That's the part that checks if everything was stable during the test. You can think of the response times, the CPU being used, and the memory being used. Are they constant over time? Those are all analyzed automatically, saving at least 1 or 2 days per analysis. Another big win is that we can compare 2 test runs. By selecting 2 test runs, we can see if things get better or worse using an effect and base measurement. So you start out with a base measurement, you have your new release, you run another test, you have the automatic report, and those 2 reports can be compared instantly. The last big win is that we can see trend. So over time you can see if the performance of the program is getting better or worse. Now I will explain how the daily stability test works. The daily stability test is what the automatic load stress test actually is. It generates a report based on a test run that runs throughout the night, and in the morning you will have your reports available. Here we see the building blocks of this setup. The big red square represents the Auto LST central server. That's where everything comes together. It's like the spider in the web. Here the scheduler runs. The test run analysis is being created. The heap analysis, the memory analysis is being done. Then we look at some other parts of the blocks. The orange block is Jenkins. That's the continuous integration pipeline. Part of that, we have created an Auto LST plugin. This plugin will actually start a test when Jenkins says the build has succeeded. Then it will also report back at the end of the test run, which runs throughout the night, to say to Jenkins if the run was successful or not. Based on this information, the continuous integration can continue or stop in the build pipeline. When Jenkins asks the Auto LST Central for a load test to be run, the Auto LST Central will run the scheduler and start the load test. The load test is started at the load generator. And the scheduler will ask the environment tool to restart the server, do the heap dumps, and it will talk to the Auto LST agent on the server under test to accomplish other tasks, such as collecting the data after the test has finished. After the test has finished, the report will be generated and can be seen in the blocks that are highlighted with the blue square. We have the report browser and the report store. That's where the actual reports are being made available to the teams. This is an example of the single report browser. If teams go to this page, you can see all of their runs they see the run times, they can click on the link, and they will get to the details of this test run. Here you can also see the blue buttons on the bottom to do an actual compare between two runs and to generate the short report, the management summary. So, if you select two checkboxes and you press compare to test runs, it will bring you to this page where you can see a list of all the metrics that we check during the auto load and stress test. It starts at the top with an analysis of the access log, and it goes all the way down to check system performance, like the CPU. The test will actually check if the response times are being constant during the time, and if they are growing or getting less, then you get a red sign like the two red squares on the top of this report. This is an example of the management summary. This is when you click the management summary button, this page will show up. And actually here, it reports in text and in smileys if the test was successful or not. Basically, it compares the base run and the effect run, and it states a comparison between the two. So also here, it compares if, for instance, in the base run and the effect run, the CPU would increase with 5%, it would create a yellow smiley to say, hey, warning, something's wrong with your CPU. The new release spends 5% more CPU than the last release. And the team can have a look at what happened. This management summary can be easily copied and pasted into an email, and it can be sent out to teams and managers, and can be used to implement the new version of a release into production. Here is the overview again, and now we'll have a more detailed look at the test run analysis component. That's on the red square, totally to the right. It's highlighted with a blue marking. This is the result of an automatic LST analysis. Here you basically see all of the values that we saw in the compare report, but then one by one on a line. And here you can also see the level of severity that is found. If it's green, it's good. If it's red, it's not good. It's critical and it needs to be looked at and it needs to be fixed. In order to fix this, you can click on one of the blue lines at the analysis part, and it will show you the details. For instance, if you click on the top blue line for the analysis, you get to this page, and it will show you the behavior of the whole load test. Actually, here we are looking at the average response time per request, per HTTP request, and they are grouped per 5 minutes. You can see the orange lines, and that's the time frame in which we do the automatic analysis to see if things are stable. In this example, you can see that the average response times go up slowly, and that's a sign that something is getting slower. We put continuous load on the system, so we expect everything to be constant. So if response times are going up, then something is causing the performance to get worse. Here we see another screen. This is the average number of requests per second, and then grouped per 5 minutes. So here you see the actual load on the system, how many HTTP requests are coming in every second, and that's constant. This is for the same test, so the increase in response time does not correlate with an increase in load, so we have to look further. Here you can see that the fit line is green, indicating that it is stable enough to go to production. In this final slide, you see a piece of the scheduler. This is what the actual scheduler looks like. And next to that, you can see how it translates into a test run. First, there's the cleanup of files on the remote server under test. Then we have a server restart to clean out all the memory that's in the server and to reset all the properties and settings for that server. Then we have an initial heap dump for later detailed heap analysis. The load will start, and then later on you'll see the vertical orange line, and that is the start of the test analysis phase. That's where we check if all the metrics are constant, being CPU, memory, number of connections that are opened, etc. This analysis phase ends at the second vertical orange line, and then we see the green vertical orange line that will indicate that the memory analysis starts. In that part, we'll call the system garbage collect. So we do explicit garbage collect on the system to make sure that all the garbage is collected from memory. And there we can see if there memory leaks are present. And that phase will last until the second green line. The little bars on the bottom tell you that system GCs are being performed. At the last part, the load continues, and we make 3 heap dumps. Those are memory snapshots, so we have a vision of the complete memory behavior. These will be automatically analyzed in the memory analysis. We perform 2 of these heap dumps under load, and 1 of the heap dumps is without load, and there we can check if all memory is being released after the load on the system is gone. And finally, we have a log file or data collect that will be used to do the analysis. So this is a wrap-up of the auto load and stress test introduction. The benefits of the auto load and stress test hopefully are being made clear. We can do more tests in less time. We have faster feedback for the teams. There's less effort in analyzing and finding performance issues. And hopefully in the end, we have less performance issues and happier users. Thank you for your time, and I hope to see you in the next episode.